have various hazardous situations, dangerous situations, wherein you don't want people going in and getting killed. And you don't want property to get destroyed due to errors due to human errors or due to malfunctioning of equipment. So what we do is we provide a mechanical, sometimes electromechanical or electronically backed up safety system which works to keep things in order when all else fails. No matter whether there is an electrical failure or a failure of the backup power supply or what else, still the mechanical system is so designed so that when everything else fails, you still have a mechanical system which will prevent somebody from, say, foolishly entering a high voltage area or something like that. So how we do this is we design it so that all the entrances for, say, of an electrical installation have gates fitted with locks, and the keys of these locks become part of the equipment. So you need to extract the keys after locking up to switch on the main generator or transformer or any switch gear, everything. Similarly, we also do what we call sequencing. If you take a process industry, you want to make sure that it follows the prescribed process, and if there is a violation of the sequence, then the interlocking system prevents it. And then if there is, say, a system like a high voltage system involving capacitors or moving parts like flywheels, wherein even after the power is switched off, the place is still dangerous. So you don't want people to go in such places until a certain time has elapsed. So we provide electromechanical solutions in these cases. So we have been in this industry for about 40 years now, and we have been developing new products and new solutions. We not only just supply the interlocks for safety, we also design and supply the entire safety system. So with the IoT buzz coming in, we thought, why not next move to smart interlocks? And we started something called the Project Inlock, the intelligent interlock as we called it, to make it suitable for the connected world. In fact, my association with TW started off with this project. We had made this project and we were looking to partner with somebody to take it to the next level. So that's when we got into talking to ThoughtWorks and a few other people, of course. And of course, in between, there were issues because of which we didn't take it further. And right now, the product is in a stage of maturing, and we are hopeful of launching it very shortly. Okay, this is just a sketch of a typical installation and what we are trying to do in this project. Let's say you have an industry and you have an electrical installation, because interlocks are widely used not just in electrical installations, they're used in cement factories, steel plants, paper mills, railways, mining, so many different applications. So depending upon the application, the interlocking system changes. So irrespective, and the configurations change. So we are trying to build a system that would be a uniform solution to all the IoT needs of various kinds of systems. The rest of it is simple. We have so many nodes which receive the input from the sensors, and then they talk to a local server. The local server talks to the cloud, and then the cloud talks to the clients, and so on, which I guess all of you must be very familiar with. There were, of course, issues like when you take the practical aspects of such a system, you had to worry about, say, the system should be both a peer-to-peer as well as a client server, the architecture. And then when the local server talks to the cloud server, we had to face issues like regulatory information not being stored outside the country because we have clients spread out all over the world. And a lot of stuff like information on the, say, data from electrical installations, no country wants to share it with another country. So they want their own database and all that. And then we had issues of many of these systems being working on BOT, build, operate, and transfer. So in which case, very often we had to span several countries. So these are the bugbears that we are just sorting out right now. While doing this project, we found that there were certain constraints which made industrial IoT quite different from your domestic IoT. You see IoT in so many things nowadays, like for example, your door locks or your lights, fans, and your home automation and all that. But there, if something fails, you have a user to reload the whole thing, and nobody really cares much. If at all, it's a nuisance value, and after a certain point, your product may not be appreciated or so. But if you patch it up, fast enough and react to the feedback that you get from your customer ends, you still can make a success out of it. But unfortunately, with industrial IoT, you don't have that luxury. You have to get it right the first time, which is why we are taking our time. We still have our pilot this thing set up, which we are offering free to our customers right now. But we want to see how it goes and where it goes before we launch it as an official thing. And so here, I would say probably some of the critical design constraints would be data transfer reliability, real-time data transfer, reliability of wireless connection, and security. When I talk about data transfer reliability, I'm talking about the loss of data. Again, like I said, if you lose data in a domestic project, it doesn't matter. But here you cannot afford to lose data. You lose a few packets of information, you may lose an alert signal, a signal that something has gone wrong with the plant, and that can be totally unpardonable. And here, any loss is a tangible loss. Late delivery. You have several nodes connecting to one local server, and so if they are all on the same link, and you use a polling method or something to access the various nodes. By the time the last node communicates to the local server, assuming that there is a small time lag and the last node is the one which has the alert signal, you may lose a few precious seconds. Those precious seconds could be used to turn off the supply or to take corrective action. So you have to be very careful of the number of, the load on each link, and to ensure that not only the links, the total network itself does not get overloaded. And industrial spaces often have, a typical space would have something around 300 to 500 nodes, and some of the nodes would be connected to, say, about 48 devices. So you can imagine the kind of load that we are talking of, even on a small, I'm talking about a small scale, say, paper mill project. In steel plants and cement plants, it would be larger. Reliability of the wireless connection and redundancy. Yeah, the wireless connection, Wi-Fi, unfortunately, I would say in India is still not good enough to talk about implementing IoT in the industrial spaces as yet. We have tried to put up this in a remote site in a place called Bhadrachalam. Okay, and there we found that in spite of our repeated attempts, the network keeps going down. Which is why now, in fact, we are trying to put up the pilot plant somewhere outside India. So, the reliability of the wireless, I think, is something that we are quite far away from what is required in India. And in addition to the existing infrastructure, your own internal infrastructure, you need to build it so that you have sufficient redundancy in the routers and the other local equipment to ensure that no single failure can bring down the system. Coming down to security. In my opinion, security is probably going to be the key factor which decides to what extent IoT is going to get implemented in industrial spaces. Some time ago, Mr. Shiva, did I get the name right? Correct? Okay. And he was talking about driverless cars. The reason why it has not taken off is probably the incident with the Jeep. I'm sure all of you must have read about it, right? The Uconnect. So now they are talking about raising the security levels of automotive communication to the federal levels. But is that secure enough? I don't know. After all, we have heard of the White House being hacked into, right? So security here, if we go to every single thread in this communication has to be ultra secure. When a guy who volunteered to drive the car in that Jeep incident got psyched out when they took over his car, just imagine something happening like that to a guy on the road. Or worse, just imagine something happening to an electrical installation like this. Right? It could be totally disastrous. So I don't think anyone would be really willing to go in for an IoT in an exclusive IoT solution in a critical location like an electrical installation. In addition to these design factors, there are of course other basic management related factors like cost, ease of installation, ease of maintenance, whether it should be a specific or generic solution, and other futuristic plans that we need to take into consideration. When I talk about cost, now it's no longer just a pure software cost. We are talking about mixing the real world with the IT world, the physical world with the IT world. So the cost has a hardware and a software component. The hardware is of course the nodes and the network, and in addition to the basic equipment to which it has to all be tied up, and the software and the firmware, and whether the cost at which we offer this product justifies the benefits that we get from it. Ultimately, after building the product, will we be able to sell it? That is a very important point. And the ease of installation, you need to be flexible, no industrial space is static, and you need to be able to retrofit because most of the installations are up and running. You can't go and expect them to tear it down just to install your setup. And you need to be able to ship emergency replacements. And then ease of maintenance. You need to be able to provide over-the-air updates. You need to do remote troubleshooting. And once again, emergency replacements. The reason why I put emergency replacements both in ease of installation and ease of maintenance is, unfortunately, industrial projects don't happen in a day. So you may ship the product today, but by the time it gets installed, it may be 18 months or 24 months from today. By that time, you may have changed your entire product. And technology is moving so fast that by the time the product is actually in operation, the technology may be outdated. So how do you handle this? How do you handle emergency replacements? Specific or generic? So suppose I offer a solution for interlocks with IoT. Some other guy offers one to take care of all the transformers requirements with IoT, and some other guy for switchgear and so on. The guy who's running the plant is going to have about 50 different apps running on this system, each telling him others for various reasons or logs from various things. He would much rather have one single solution that could give him a comprehensive view of the whole plant. Now, what we figured and what our customers came back and told us is, see, you're giving the status. The interlocks are just like state machines. So you're giving us the status of the switch gears, the access doors, and all the equipment connected to the switch gear down the line through your interlocks. So once you give that, you're actually giving us information as to how long a particular machine is running, the timestamp stating when it's turned on, when it's turned off. You're giving us information of which of the machines that are running in parallel. So effectively, what is the utilization of each equipment? What is the downtime? And so this information can be a valuable tool. So why don't you add analog input facility also to it? So that's just what we have done now. So now we are capable of handling inputs from pressure devices, temperature devices, Buckles relays, magnetic oil level gauges, and a whole range of equipment, so which we think will be a more acceptable solution. And of course, the futuristic views, I think these are common to both industrial, domestic as well as industrial IoTs. Very soon we're going to run out of bandwidth. We're going to have to figure out other solutions like visible light communication and all that, and data storage. Okay. Now, whatever we've done now is nothing new. It's already been done under the name of SCADA, with the exception that right now it's a wired solution. So for those of you to whom SCADA is a new term, SCADA is a surveillance, control, and data acquisition system that's already in place, and they use traditional Ethernet connectivity in SCADA systems, which is, strictly speaking, more reliable than the IoT solutions. But of course, SCADA has its own issues. Wiring up a SCADA system is not easy, it's expensive, and when you have an industrial space spread out over several acres, then wiring up every single device can be a pain. And if you want to make any changes in the system, then you have to rewire the whole thing. So there, wireless would be a huge boom. So after wondering how we are going to convince our customers to go SCADA or IoT, we finally figured it out that it has to be a marriage of the two. Your system should be built such that it can both accept a wired solution for certain parts, certain components, and a wireless solution. And based upon the requirements in that location, we'll have to figure it out. So, after working on this project, we had a lot of takeaways. We kind of figured out that not everybody is ready to jump into an IoT project simply because IoT is not a total blessing. Sometimes you have to use it with discretion. Just because something is new or something is innovative and interesting is not often the best solution. So what I would suggest is now what we are doing is certain components which are critical, which would be like playing with fire. Let us stick to the traditional solutions. Maybe I'm a dampener here on this whole IoT conference, but still I think we need to use it with rational, and we should not get ourselves into situations like the Jeep incident on a larger scale. On this note, thank you.
Any questions from the participants?